Hi guys. So when I originally started to think about this, I didn't really know how I was going to interpret different stuff or what to show. But then I actually started playing with different stuff in Geometry Sketchpad. And I was thinking about some different things that I thought were pretty cool about angles. Um, I'm used to, and I guess I should have drawn one. When I was growing up, we always just had the angles. I mean, because I didn't have as much geometry, we didn't always have look at the geometry of intersecting lines as much as they would just give us an angle like this. They would label it, and we'd have our angle here. And so we can bring that over more so I can have it in the center. But so I always just dealt with this, and I never got to think of it as much as with intersecting lines. So that's pretty cool, especially for me with the complementary and the supplementary. Um, Understanding now where that comes from, because we know our angle 4 here and angle 3, if we look, will always equal 180, and I can even do that. And so if we add these two together, it'll always equal 180, and no matter where, I forget which one I can move, no matter where I move my line, it's cool because this always stays 180. And so I think that's pretty neat to finally understand that and see where that's coming from, instead of just giving us two of these angles right here and saying, how do you know they're supplementary? And so that was nice for me, and seeing then why are these the same? So that no matter when I moved here, the second and the fourth angle were always the same. So KLN and OLM always had the same measure. And so it's pretty cool seeing that now, and understanding the adjacent, because all of their sides are very similar. And so by moving the different lines, we're still not changing our different rules here. And then it was nice to see this as well with the parallel lines. So here I have the parallel line. I have my first line here, and I could have labeled that. So we have line J and line K, and so they're parallel, and then we have this other line here, L, and that's the transversal cutting the lines. And it's cool to see that no matter where, I have to remember which one I can move, no matter where I move the transversal, we always see that it's the same two measurements. And it's pretty cool seeing how angle 1 and angle 6, even though they're not next to each other and they're kind of in weird directions, and what would they be? And if we look at it based on where they are, no matter where I move these two, they're actually, put that back, sorry. If we look at 1 and 6, they're actually 180, because if we think about it, between the two of them, we create a straight line. And so that was pretty cool. It was also neat to see, forever they always just tell you, a circle has 360 degrees, but never explain why. And I thought it was cool when I was thinking about, I have to do it from points. Oops, not one, sorry. If I was thinking about how we draw our angles and we label them, if I'm talking about angle 2, I would use that to talk about the measure. Well, if I do this for each of them, I've never realized when you put all four together, the different arcs actually make a circle, which is nice to see. That's why it equals the 360. So I think sitting and working with the kids and showing them how it's broken down, it understands more where it's coming from. Because I know I personally never really understood why a triangle was 180 or a square was 360 or a circle was 360, and why these different things were. And with the shapes, I get it, because you can add the angles. But in a circle, it's harder to understand. So I think this is pretty cool to see how you get the 360, and we see this with the different lines, and then also how we see what's related. And so how we see that 5 and 1 are congruent, or 4 and 8, or 3 and 7, or 2 and 6, and seeing how the different angles in the different lines are actually congruent or supplementary based on making the full line.